My name is Johan Högfeldt. I am a developer at my own company called Hammerwatch, which is actually it's actually a consultancy, and I'm not a game developer from the beginning, but I have been involved with creating a game called Hammerwatch, Coliseum in Defold, and that's why I'm here today. And the reason for me showing that I'm not a game developer is because that's kind of the point that I have created I'm the lead developer of a game that is fairly complex, and through this process I have learned game developing through Lua, and I want to share a little bit of the gotchas and the new experiences that opened up for me being a systems developer creating a game. And to start off, I would just like to show a short little video of the game that we have been creating. And there's no sound now, but it's not so important. So it's a pixelated hack and slash with a lot of action going on, where you fight these monsters in an arena of. So as you can see, that there's a lot of stuff going on, and all this is, as Ragnar has been telling about the Defold engine. Did I mention I've created in the Defold engine? Yeah, sorry.
That's not the frame rate of the game, right?
No, exactly. It's not. This is so this is a video that's actually captured within the engine itself. So that's just a little nice side feature. But the story behind this is this game, Hammerwatch, is a hit for PC that's been available on Steam for quite a while. Some of you might have played it. I'm not involved in the original game, so give me no credits for that. But the guys who are who created that game are actually neighbors to a friend of mine. And when some time ago we decided we wanted to create a game, me and my friend, and he approached these guys and asked if we could create a mobile version of their game. And that kind of coincided with me knowing Ragnar and have been playing around with Defold since before they became part of King. And I said maybe we should try to do it in Defold, and then it turned out they were releasing Defold and wanted someone to maybe create a game that could be like a pilot case for the engine. So that all kind of coincided very well, and so we got a lot of head start by using this game that had assets. We had sounds, we had graphics, we have a lot of know-how from some really good game designers. So that's why we chose to do this game, and so I just kind of jumped in head first and thought this will be easy doing because I've used Defold before, and I maybe this was in March. I want to tell you as well. So maybe if I'd known then what I know now, I would have chosen something a little bit more easy, but. What I've learned, the big things that I learned fairly quickly that I didn't know before, is this frame rate in games. You all know that. You have each frame, something needs to happen. The frame rate of our game is 60 frames per second, which means I have 166 milliseconds. No, 16 milliseconds. To finish all calculations for the next frame. That means every row of code really matters, and things that I'm not used to. I've created things for the internet and for desktop applications. Is that you need to pre-calculate a lot of things. And you need to do something called time slicing, which if you're not a games developer, you're probably not that aware of, where you divide lengthy operations between frames, and we'll come back to why Lua is a particularly good fit for that. And then also you have the real-time AI with stuff that needs to. We have a lot of enemies in our game, and all of those enemies need to act in a way that at least they need to at least seem dumb. And that means they need to do pathfinding, which is if the player is behind a big chunk of walls, they need to still be able to go around those walls and find their way to the player without just bumping into the walls. And that is quite, it's not a very complicated algorithm, but it's an algorithm that's not always for 100 enemies in a room full of walls. It's not always easily done in 16 milliseconds, along with a lot of other calculations. They also need to keep clear of each other, so there's something called steering. And for the guys here who are game developers, things like pathfinding and steering and flocking, that's just concepts you know. For me as a web developer, that's not concepts I know. I do very little steering and flocking on my websites. And then you have this inheritance versus behaviors. If you come from the classic object-oriented programming world like myself, and even in a normal use case of Lua that's outside of game developing, I would say that you do some sort of object inheritance where you have functions that objects inherit. But in a game, that's not always the reasonable way to go, because you can have an enemy that, in our case, you have an enemy that can walk. All enemies can walk, so they have a behavior code that you want to attach to it. But in normal inheritance, you would have something called movable, and that movable thing could fly, and another thing could maybe walk, and that's two different classes. But then what happens if you want to both fly and walk, but at different times? And then you would need to have some sort of combined class, and you will very quickly have a lot of code duplication. So I think my experience when you create games, it's much better to have behaviors where everything is just, you have a script with a behavioral approach that controls the behavior of a game object in a very, very limited scope. Stop me if I'm very... and then, I mean, don't get me started on rendering and all those things. That's very new, but that's not for the scope of this. So, Lua. While Lua is for me a good fit for games, is of course that it's fast. As Ragnar pointed out very many times, that's essential. Since you have 60 milliseconds, you need to, even if every code matters, sometimes you need to have a lot of code, and you need to know that you can when it's necessary. It's very dynamic, and by dynamic I mean it's flexible, and I mean flexible is kind of a synonym to dynamic, but for me, what has been very beneficial is that we have been able to fit the language to our needs and do stuff with the language and with its dynamic ways that makes us fit the language to our needs instead of adjusting our needs because of some limitations in the language. And I mean that's not maybe unique for games, but I think it's maybe more common that you create like behaviors and stuff they work fine for all the enemies, and then along comes a dragon or something and just spoils everything because it works in a whole different way. And then we have, for me it has been very good to be able to monkey patch stuff and redefine system functions when you just want to, for instance, especially while testing, I have a lot of functions that where we have a network class, and I don't want them I don't want to use the network. I want to control everything locally because I have some other guy working at getting the network functions correct. Then it's just good to be able to just monkey patch over those calls and catch them and do whatever I want while he's working on the real implementations of stuff. And the enclosures have been, for me, something that is very, very powerful in Lua. Being able to have to know the value of a variable within a function or something like that. And then coroutines, of course. As I said, time slicing demands that you sometimes slice the work of a length function like pathfinding between frames. Then coroutines is fabulous because you can just say, find this path along this, and then if you haven't found the path, give me back control and let me jump to the next frame, and then we'll continue. So the enemy can be a little disorientated for a while, and then it will find its way. And since the frame is 60 milliseconds, even if you time slice that over 10 frames, it still means the enemy will find its way in under a second. So I don't think it will be that seem very disoriented anyway. And then, of course, Lua has a big community. So finding already made algorithms like pathfinding isn't that hard. So that has been, for me, again, not being a game developer from the beginning, that's been very helpful, finding stuff that works and that's been tried and then just adjusting them to my needs. So if we look at Defold, to start with, as a define tool, as Ragnar mentioned, we have game objects that contains components, and the components can be sprites, they can be sounds, it could be particle effects, and they can be scripts, of course. And I mean, we are a group of programmers here, and so this might not be a very important point for you, but I work with people who, when we create a game, we of course have people designing the graphics, we have a sound designer, we have game designers who create levels, who know nothing about programming. And what Defold lets me do is I can expose properties on the scripts and use animations that they create without them having to bother with the code. I can just tell them, set the property on this script and that will be fine. Or they can create a map or a level, and I can just use it with my code. Yeah. And also the built-in Git support. I myself use command line Git, even when I use Defold, because that's easier for me. But having people not very experienced with Git, just being able to sync stuff, creating a level and then just pressing a button and it's synced to the Git repository, that's, while still for me having the power of using command line Git, that's awesome. But we are programmers, so we have the scripts that are created in Lua. They have these lifecycle functions that are called by the engine, as Ragnar said, at certain points, like onMessage. We have an update function that's called every frame. There's also an onInput, which takes input. But they can also be message passed either by the system or by another component that I have created. So Ragnar has already spoken about this question, but we can also create Lua modules besides the scripts that encapsulate common functionality and let us avoid code duplication. So I have the pathfinding, for instance, is not maybe in a script, it's maybe in a module that can just be imported by anything that needs to do pathfinding, or I have helper functions for doing a lot of stuff. And I would like to just briefly show the actual code, although a bit simplified, of one of our game objects, just to show how this is actually used in our game. The game object we're gonna show you is the arrows that one of these guys shoots at enemies, and this is how it's set up with a game object that contains a number of components. We have a collision component that can detect collisions, and if it takes a collision, it will send a message to all scripts within. We have two scripts, which are two behaviors. This is a projectile, so it's an arrow, and it will damage stuff. So it has a damage behavior. We also have two sounds. You'll have to yell for Ragnar. I don't think that's a very obvious sound item. But the hit and shoot are two sounds. And then we have a sprite. And the sprite is a graphical component that contains animations. And in this case, it has animations that, one animation for each direction that the arrow can go in. North, and they're named after the geographical directions they point in. And in a normal game that's not pixelated, you will probably just rotate the arrow, but we want it to be, we have drawn it with pixels in each direction. So it's a fairly simple object. And without actually going into the properties, I just want to show you that in a script, I can define properties like will damage player that controls whether this particular arrow will damage a player or not. And then my designers can set these properties in the UI. And this is what I talk about, where I can create code and let other people do the designing. So without going too much into what each property do, I just want you to see this. And then we have the script that controls the behavior as a projectile, and this is the init function, which is called when this component is created. So the component is created from another game object, of course. That could be a player or it could be an enemy that create this. And it will call the init function, and then I have a little helper function that will check what the direction this projectile is going to and do the conversion from a trajectory into this string that will control the animations. I'll tell the sprite to play that animation. Calculate distance. Don't get too much into that math, but it calculates a distance and the speed and how long it will take for the projectile to get to its max range. And then I animate the position. We can go through this. Just the dot is just telling it it's the game object that this belongs to. Animate the position once until it gets to its target position. Do it linearly, so it won't increase or decrease its speed. It will have constant speed. Do it for a number of seconds without any delay, and then delete it. Simple as that. And then play a sound. That's all there's to it. And the reason there is one more thing. The reason for animating in this way and not controlling myself through the update function, which I could of course do, is once again the little amount of time we have. This is a little bit more efficient, of course, letting the engine animate it instead of doing it myself in Lua. And then there's one other lifecycle function, the on message, that Ragnar also showed previously. So we only listen for one message. We listen for a collision, and if that collision is with a wall, then delete it. So our arrow cannot go through walls. And then we have a damages script that also, it's the same, it only has an on message that looks for collision responses, and if the collision collides with something, then we have then we send a message to the thing that it collides to and tell it you are damaged. That's it. We let the receiving end decide what to do with the damage. So with that little script, because of everything, we can just, we don't need more than that to have something going over the screen, being distracted by walls, being distracted when it reaches its destination, and inflicting damage on anything that's in the way. And that's actually it.
I have one question actually.
Yes.
Can you go to the previous slide?
Yeah.
What is this MSG? Is that something internal by default, or because there's
This is the what Ragnar said. He simplified this way of because he didn't want to show this, I guess. This is the way you actually MSG is the way to pass messages in default. So msg.post will post message, msg.url will give you the URL confirmed.
MSG is the namespace.
Yeah. Yeah.
Do you have an example of using a content? How do you deal explicitly with the symbol, or eventually just?
No, not that I can show like this, but I would say the main the best example is actually the pathfinding, where you have an enemy that needs to go from point A to point B, and there's a lot of walls in between. And if you have a lot of enemies doing that, they will, of course, that process takes a long time. So in the pathfinding I use is called A*, which is a fairly big algorithm for that. And when I have certain checks that when it gets to depth, like an arbitrary 5, if it has gone 10 steps and still haven't found the player, then just yield, and in the next frame I will ask it to continue its pathfinding.
So you will have a pending message call, and then you will resume the next frame?
No, in that case I would have like a general script that just updates stuff. I have a script that I know will be called in every frame, no matter what, like a controller script that updates stuff, like check if there's any pathfindings not being that has not been resolved. In that case, yield them. Check if there's any. I also have other things that I know is lengthy, so I stuff them in a table and maybe do 5 of them each frame. It can be stuff like ray casting, which is looking for straight paths, and or setting off timers or something.
You end up building a scheduler.
Yeah, kind of. Yeah, exactly. So I have an object that just controls global stuff like this and clearing internal queues. Yeah.
What is the total size of application after you finish your game?
It's quite big, but that's because we have a lot of assets.
So, following questions: is there some system to actually split the assets and download specific assets from the requirement? I'm going to specific level, and I have to download only the assets that are used at this level.
download like from the internet or something like that?
Yeah.
No, no.
So everything is in the one bundle, yes?
Yeah, exactly. And I think, or I know we have some pre-release or preview version of this game too. It's available on Google Play since June, and I know then the limit was 50 gigabytes, 50 megabytes. 50 megabytes of data, and I know we just got on that limit with all the assets, and we're going to get over it now, but Google has thankfully increased that to 100. So, but I actually don't know how much of that is assets and how much is engine, but I know the engine is very small. I can vouch for that. Ragnar is correct. Most of it is assets, like 99%. Yeah. Yes.
You mentioned the integration to, is that exposed to Lua too? So is there a library for that? Or
The what? Sorry.
Git integration is
Yeah.
available in the scripts, or it's a low-level thing of integration?
No, it's in the engine. I can't control the Git integration we was given. Ragnar has something too.
But it's not even present in the engine, the integration. It's just a means to share and work on the assets that then are compiled into them. So once you're in the engine side, there's just a set of components that then be placed on.
Yeah, did everyone hear Ragnar?
Oh, sorry.
Yeah.
I should have said it loud.
No, it's okay. The Git integration is in the tool, not the engine. That's the short version. Yeah. Good. If anyone wants to know more of anything specific, I will be happy to show you later. Thank you.